Dear learners, greetings. This is Vimal Joral from the Department of Computer Science, St. Joseph's College, Trichy. In this module, I'm going to introduce digital number system. Digital number system is the base concept to understand digital computers. We have got different number system: binary, octal, decimal, hexadecimal, out of which computers do not understand the way we feed. Maybe if we feed 5 into computer, which is a decimal number, the computer does not understand. So to make computer to understand and to further computing, we need to convert one number system to binary, because binary is the format which is understood by the computer for computing. So my dear friends, in this module, we are going to clearly understand the different number system, their base, ranges, and so on. And I'm going to give you a short demo on how to convert a decimal number into binary. So let us go in for the lecture, followed by the demonstration. My dear learners, this digital number system comes under the course 25 UCS 13 CC2 Digital Computer Fundamentals. And the first topic is digital number system. The various number systems are binary, octal, decimal, and hexadecimal. And in the table, you will find the base for each number system and the range. Let us go in for the details. Binary number system. The base for binary number system is 2. So with the base, we identify a particular number system. The range for binary number is 0 and 1. There are only two numbers, 0 and 1. It is 0 to 1. There are two. Binary numbers could be converted into octal, decimal, and hexadecimal. And the next number system is octal. The base of octal is 8 and the range of octal is 0 to 7. Totally 8 numbers. It starts from 0. 0, 1, 2, 3, 4, 5, 6, 7. So 0 to 7. And it could be converted into binary, decimal, and hexadecimal. The octal could be converted into binary, decimal, and hexadecimal. And the next number system is decimal. And we are all very familiar with decimal number system. The base for decimal number is 10. And the range for decimal number is 0 to 9. Totally 10 numbers starting from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So totally 10. It starts from 0. And this decimal number could be converted into binary, octal, and hexadecimal. Now the next number system is hexadecimal. The base for hexadecimal is 16. And the range for hexadecimal is 0 to 15. But there is a small change here. After 9, we don't write 10. Instead of 10, we represent it with the characters starting from A to F. For example, 0 to 9, you have 0, this 0, 0 to 9, and the 10 is written as A. 10 is written as A, and similarly 11 is written as B, 12 is written as C, and 13 is written as D, 14 is written as E, and 15 is written as F. So totally 16 numbers. It ranges from 0, 1 to 9, and 10 is represented by A, 11 is represented by B, 12 is represented by C, 13 is represented by D, 14 is represented by E, and 15 is represented by F. So this hexadecimal could be converted into binary, octal, and decimal. Now let us go in for the demonstration of decimal to binary conversion. It is a very, very simple mechanism of converting a decimal number, a whole number, into a binary number, which could be easy for computers and computing devices for further computing or for further processes. So we have a small number taken for an example. I shall demonstrate you with a small example. We have 25. How do we identify this 25 as decimal? Because the base given here is 10. So it is a decimal number, right? Now, let us take this 25 and divide it by 2. Okay, when we divide it by 2, so we have the result is 12. 12 times 12 2s are 24, and the remainder out of 25 is 1. Once again, when we divide 25 by 2, we get the remainder 1 and the quotient is 12. So I write the quotient here, 12, and the remainder with an hyphen. Okay, I write the remainder with an hyphen. So the remainder for 25 when we divide it by 2 is 1. And similarly, again, we divide 12 by 2. The quotient is 6. The remainder is 0. 6 2s are 12 and the remainder is 0. And similarly, we should proceed until entirely it is divisible by 2. The number divisible by 2. Now, 6 is again divisible by 2. The quotient is 3 and the remainder is 0. So I have written the quotient 3-0. The remainder is 0. And again, now 3 could also be divided by 2. So I go for division by 2. Now it goes for 1. Okay, 1 into 2, 2. The remainder is 1. So I write it 1 quotient and the remainder is 1. So I have obtained the remainders, until 1 cannot be further divided, right? 1 cannot be further divided by 2. So I have obtained 1, 1, 0, 0, 1. So it should be written from the bottom. All the remainders should be collected and written from the bottom. So it is actually 1, 1, 0, 0, 1. So we should write it 1, 1, 0, 0, 1. Don't forget to put the base as 2. So the answer for binary conversion from decimal 25 is 11001. So I repeat, see, any decimal number that has to be divided by 2, the quotient is written and the remainder either 0 or 1. When you divide a number with 2, you get only 2 options, 0 or 1. So write either 0 or 1 as a remainder aside with an hyphen and complete the process until the number is divisible by 2. Once you cannot further proceed, when you are not able to divide the number by 2, when you obtain 0 or 1, you just start writing from the bottom. From the bottom, take the number from the bottom. So here in this case, we get 1, 1, 0, 0, and 1. So that is written from the bottom, 11001, and don't forget to put the base to identify it is a binary number. Just for another example, 40, 40. So 40, as I told you earlier, I divide it by 2. The quotient that I get is 20 and the remainder is 0. So I just put it. Whether you get it 0 or 1, you will have to write it. And the next, again, I just divide it by 2. Now this time 10 times 10 into 2, 20. And the remainder is 0. Similarly, I go for dividing 10 by 2. 5 times 5 into 2 are 10. And the remainder is 0. Now, divide 5 by 2. 2 into 2, 4. And the remainder is 1. So I write it aside. Now again, 2 can be divided by 2, right? So 1, 2s are 2. The remainder is 0. Okay. So I have got the number 1, 0, 1, 0, 0, 0. So it has to be written like this. 1, 0, 1, 0, 0, 0. So it has to be put up with a base 2. So the binary equivalent of 40 is 1, 0, 1, 0, 0, 0. This is binary equivalent of 40. So this is how the decimal number is converted into binary. Now I hope all of you have understood this mechanism of converting this decimal into binary. Now my dear friends, after having understood the mechanism of converting decimal into binary, you can try yourself with the number 75 with base 10, that is decimal number, 125 base 10 decimal number, 242 with a base 10 decimal number. So I want you to try on your own and get the binary equivalent. Now, my dear friends, I shall just repeat what I have said so far. I have at the beginning told you about different number system: binary, octal, decimal, and hexadecimal. The base for binary is 2. The range is 0 and 1. The octal number, the base is 8. The range is 0 to 7. 0 to 7, totally 8 numbers. And decimal number, which you are very familiar with. The base is 10 and the range is 0 to 9. The last is hexadecimal. It goes up it goes with 16 numbers. The base is 16. The range is 0 to 9. We are not supposed to write 10 as 10. Instead, 10 is represented by A, 11 is represented by B, 12 is represented by C, and it goes up to 15, and 15 is represented by F, A to F. 10 to 15, A to F. And we have also seen the demonstration of converting decimal into binary. I repeat the mechanism to convert the decimal into binary. Take a decimal number and divide it by 2. Get the quotient and write the remainder aside. You get the remainder either 0 or 1. Just with an hyphen, you write the remainder. And further, with the number, divide it by 2. Repeat the process until the end of a number which you cannot go further division with 2. So write it iteration by iteration. And at the last, when you cannot divide the number by 2, you write the numbers, reminders from the bottom. So write it one by one from right to left. So it is binary equivalent of decimal number. I hope all of you have understood the different number system, their base, ranges, and the conversion of decimal into binary. The next module will be dealing with conversion of decimal. Now we have seen decimal into binary. Now binary to decimal, and with the other number system, we'll be able to convert from one to the other. Get ready. Before we meet for the next module, I want all of you to please do it yourself with the 3 numbers, decimal numbers that I have given. Convert them with binary and check yourself. Thank you. If you have any clarification, you can post your comments. I shall clarify in the next module. Thank you.